connection. So that's the beep to indicate that the truck has started to charge. And so what we're going to do is break the power, right?
Yep.
Okay, hell yeah. Can't wait to see. How long should it take? Like 35 seconds? Okay.
Yeah, you've done your homework.
Okay, cool. It's a rumor I've heard.
People here. Really glad to have you here. My name is Bidirectional.
Let's do it. Okay. So there's a power outage, okay? And then to the house.
This video is brought to you by StarCharge, the largest EV charging manufacturer in the world. They are also a provider of residential and commercial battery storage with microgrid solutions. Hello and welcome to another Out of Spec Reviews video, and welcome to a garage, and welcome to the Silverado EV RST. This is the big one, big 24 module, 215 kilowatt hour battery pack. Jordan, we love this thing.
24 modules, 24-inch wheels.
It's on 24s. We're here to talk, yes, a little bit about this truck, but actually GM Energy, which is a division under General Motors. Jordan and I happened to be in LA today and heard about this event, and I found that we were actually invited in an email that I never opened. So we said, perfect timing, we're coming over, and it is the unveil of the GM Energy bidirectional charging system, also storage, solar, all the integration. So we all love Tesla's integration, right? I mean, I filmed that video, hopefully you guys watched it, with my friend Rob Laterra, who had the Model 3, the Model Y, the power walls, the inverters, the solar, and it all worked together as a total system. And we were like, the ecosystem is crazy. Well, GM must have watched that video. I'm just joking, that video just went up. They have been working on a similar thing. And here we actually have, at this very moment in time, this Silverado EV powering this 10,000 square foot house at the top of Beverly Hills with their system. And I'm gonna walk you through the system. I, of course, wanna show you the house because it's unbelievably cool. And we're gonna meet with some of the engineers as well and talk about a whole bunch of energy stuff. So join me as we learn about the bidirectional GM Energy solutions. I love when car companies, especially those that are building a large number of electric vehicles, are focusing on the thing beyond just the consumer of electricity, which is the car, and talking about how it can be a beneficial part of your life or help the grid or other things because you have so much energy capacity. And well, I think one of the things that we've seen electric vehicles do, especially F-150 Lightning and Silverado, is use onboard power to use for certain things. For example, this TV screen, these speakers are all running off this Silverado EV RST. And so there's power cables coming out of the front trunk. They got a bunch in the rear. They actually have a charge port powered situation right over here where this is a J1772 to a power brick. I showed this at the Silverado launch, and they also have the outlets back there up to 30 amp output, 240 volts. This one's at 80% stated charge, and it can run for hours and hours running this system. So that was sort of the first step in exportable power from an electric vehicle beyond just using it for propulsion. And just being able to use the energy that you paid for, you go to a charging station, you pay, I don't know, 36, 40 cents a kilowatt hour, put it in a battery pack. It's so nice to be able to use something like this as basically a portable power brick that you can plug other stuff into. So we're used to the exportable power on the vehicles. What is interesting in this case, and something we have not really played around with ever on this channel, my friend Tom Malogny actually has the Ford bidirectional system installed at his house, and he did a fantastic overview of the installation. But what we're talking about here is that similar thing, but with GM. So this is actually exportable power, DC out. So this is a CCS connection here, actually. So I'll walk through everyone how this works. And you're able to now power your entire home from your vehicle. Now, GM says by 2026, every single GM Ultium vehicle will have the hardware and the software to support this bidirectionality. That's pretty cool, not too far away. And most of them, I believe, will have them. Jordan, we know Silverado EV RST will have them. We just spoke to an owner with a Lyric. He's getting his put in. He'll be the first one. Maybe we can do a podcast with him. A bunch of other ones too.
Yeah, all Ultium vehicles, and they said other Ultium non-GM would potentially support it in the future, but that
right,
comes
so that would be
into
like Prologue, ZDX,
Yeah.
etc. Okay, so let's walk through what we're actually seeing here. So this is your EVSE, but also a bidirectional unit. This is about $1,600.
Yep.
which is, of course, everything here is quite a bit of money.
Yeah.
And we should talk about the benefit of doing something like this versus just a backup generator. But this will charge the truck at up to 80 amps AC. You don't need 80 amps to run it though. You can derate this to whatever the maximum your current allows for your home. Because of course, a lot of panels in the house can't handle just a 100 amp dedicated circuit to run 80 amps of charging. So I think most people are comfortable with 19.2 kilowatt 80 amp home charging. Honestly, with a 240 kilowatt hour pack, Jordan, that doesn't seem unreasonable.
Yeah. That's a lot of battery to fill.
Yeah, okay. But what's different about this than a normal EVSE is the CCS connection, which you're plugging in at home, a CCS connection. And that is the DC pins are actually is what is taking energy directly out of the battery pack. We should ask, I'm curious if it's doing it in split pack or in series, if it's high voltage or low voltage. Would be interesting. We'll definitely talk about that in the interviews. And that comes back into here, which is then fed to the inverter, which is a 9.6 kilowatt DC to AC inverter. And what's interesting is it's only 9.6 kilowatts. So I guess cost goes up. You have to right size it for your home. But I think that's pretty industry standard. But is 9.6 kilowatts enough to run your house? I think it's enough to run mine, except for when I'm charging a vehicle.
Yeah.
And
Most houses, yeah.
I mean, I charge a lot. So it would be great to charge another vehicle off of this in a
Yeah.
power outage event. But I could just plug it into this, of course. So, okay, interesting. So the way that it works is, let's say there's a power event. This is, you basically lose your grid connection. This will isolate your grid connection. There's a automatic disconnect switch that happens in here. The whole process takes 40 seconds. We'll show you all how that works. DC comes out of the truck. You can even wake the truck up from a dead asleep situation. So the truck can be, sitting for a week, basically, completed at charging at 50% or 70% or whatever you want to set it to. 80% is probably what most people will charge to. It'll wake the truck up. 40 seconds later, as soon as the disconnect goes, it will start pulling DC out of the truck into the inverter and now into basically your power distribution box. This is basically a sub panel that you can hook up all the loads that you want backed up. Now, some houses, you will back up the entire house and you'll basically have the entire fuse panel in here. Some houses like this one, this is quite a large house that might actually pull more than 9.6 kilowatts by the time you have cooking on, AC on, electric heating on. They've just put critical loads on this one and also the garage lights so that we can do this video for you in light, because the house is completely disconnected from the grid right now, running off the Silverado. Makes no noise at all. Really cool. And so that's basically these three pieces of equipment. You have your power distribution box, your AC charger, your DC bidirectional, and your 9.6 kilowatt inverter that is also solar compatible. Now, my understanding is Delta does a lot of this stuff as the supplier. GM's not really confirming that, but that's just my understanding. All of this, including the dark start battery, which is really important because, of course, if you lose power, you isolate the system from the grid, you need something to wake up your EVSE, to tell the truck to start sending power back, to wake up the inverter. This is like only, I think they said 8 watt hours.
Something like that, yeah.
Really small amount of energy, but it's just enough to keep the communications boxes running until you get the truck back home or your car back home. It doesn't have to be a Silverado. It could be an Equinox EV that could do this, which is really cool. This whole system is $7,300 on the website, is my understanding, before installation. No joke, that's a lot of money.
Yeah, $7,500, but yeah, plus installation.
No, website's 73.
Oh, well,
They said 75,
yeah.
but on the website it's 73, $72.99.
Nice.
That's a lot of money for power only during a power outage, because right now this system can only work in this configuration when the grid is completely disconnected from the house. Mm-hmm. So you can't start pulling power in from the truck when electricity is expensive and blend them all together and try and save on the bill. It's just when there's an outage, your truck has to be plugged in and that will power the house. It's a pretty edge case right now, but where it starts to make more sense to me is when you start bringing in battery storage. This is when we get into the situation of a total ecosystem. I don't personally think this system makes sense without battery storage. I love the idea of battery storage. I like the idea of being able to utilize the truck more when the house is connected to the grid still. And there's two variants of these battery packs. I'll have to learn what they are. I think 7 kilowatt hour bricks and 10 kilowatt hour bricks, roughly, plus or minus, I think. And you can stack them up to about 35 kilowatt hours total. So certainly not as much energy capacity as Tesla allows with Powerwall, but I actually don't think you need that much home battery capacity, especially if you have a vehicle with 240 kilowatt hours. What you need is enough to hold your house over when you run to the store to grab milk or get, I don't know, do whatever you have to do for a couple hours in town, come back, and then you can replenish this from the truck. Now, we're not totally sure how the integration options of this and the vehicle will be with the whole system, but I'm really hoping this is actually launching at a little bit later date. This all launches today, and it's available to order, and they have fantastic, truly fantastic websites with lots of info. This I'm curious about how it will, integration options, but there's going to be an app similar to the Tesla app. We're filming on my phone, right, Jordan?
Yep.
Otherwise, I would show you all, but I'll leave a link in the description to how Tesla does all of this stuff. What I'd like to do is talk to one of the folks in charge of this project, just ask some questions, get their take on this. But before we do that, Jordan, should we show them the house?
Yeah.
Running off the Silverado?
This place is pretty cool.
Okay, so we're here late, but they had a bunch of media here today and actually GM EV owners. Cool to talk to a few of them. And this is just a cool little venue that they have.
So 2 Silverados, they have a Blazer and Equinox over here, just showcasing all their EVs.
Yeah, some of the product offerings, of course, and then you can kind of take a look at the house this way, which is, again, running completely off the Silverado EV.
So it's not just a small shack. They did say 60% of the house is plugged in.
And they said it can run for 3 days at full load.
Yes.
But that's because that's a 200 and something kilowatt hour battery pack.
So I wonder if they didn't put like all the AC on the truck or something, but
yeah,
it's pretty loud in here, pretty chaotic,
dude,
but
look at this freaking house.
this is fantastic.
It's insane.
Oh, I didn't even notice the wine on the wall. That's
Did you try their food?
I tried all of it.
Oh my
Yep.
God.
It's fantastic.
Jordan, he can only say nice things about GM now. I havenven't eaten anything.
Oh, the center
Not
plastic.
sponsored.
The center plastic of some of the GM stuff though, really bad.
Okay, so if we come around this way, you had mentioned, I mean, like just a beautiful room and everything, gorgeous outside area. We were out there earlier. You had mentioned this was not an OLED TV.
Yeah, not an OLED TV. So back to the drawing board with that, I think. Renovate the whole house.
They have like an indoor bar here. It's just a really cool thing. You'll see other creators here, like our friend Emmy Hall and Kyle Field from Clean Technica and a bunch of others that we've been able to hang out with. And there's just beautiful views of actually the entire city out this way. And it's been really cool coming here. And this entire place is running off the truck right
Pretty
now.
cool.
We're completely disconnected from the grid.
And the truck is just sipping away at that giant battery pack.
Right, so what state of charge was it at?
I think it was like 99. It was 100 when they plugged it in.
Yeah.
And it may have just dipped to 99. Like it was 100 for a while. So
Okay.
yeah, there's a lot, just a lot of energy in that thing.
Yeah, holy smokes. So what we should do is we should go back out to the system now that you can see truly how much power it's out. I mean, this is crazy. They're cooking in here, like life is going on. Everything is fully rocking.
They have a chef from some like TV chef show that won TV season or something. Yeah.
Like one of those Gordon Ramsay
Yeah.
situations? Okay. Anyway, we're not here to review food, Jordan. Unlike you stealing.
Yeah, that'll be another channel.
Yeah. What next you'll see is the Equinox is the best EV ever made from Jordan because he ate GM's food. So what we need to do is we need to focus on the backup system and maybe some of the future of GM energy beyond this. Because one thing that I really appreciated listening into the conversations, hopefully you'll take a listen on the Out of Spec podcast, is just how holistic they're thinking about electric vehicles, grid connections. All of these things can happen over time with these vehicles, but it's very early days. There's also issues with interoperability between other vehicles in this system. For example, ISO 15118-20 will have a lot of V to X, V to H, V to G communications in there, but that's not finalized. Basically, no one has agreed across the board on how the vehicles should communicate with each other. Also, we're starting to see a differentiation of DC back through an inverter or AC back straight to the power source. For example, Tesla Cybertruck does AC out and uses the power conversion system, the PCS, to basically match the frequency of the grid, match the house, and then charge through the gateway there, versus this, which is basically using an off-the-shelf available system, adapted for GM, of course, using DC out. And my gut feeling is AC out of the vehicle might be better and less lossy, but adds to vehicle cost and complexity with vehicle timelines. It sounds like GM really had to get stuff to market very quickly. But I also think we're seeing a lot of automakers still continue to go with this approach of AC or DC. So that's a question I definitely want to ask. We have a lot to learn here. And I just want to leave a plug for the future Out of Spec Energy channel. Jordan.
Yeah, and I do wonder, this is sold for actually $16.99. These can be sold extra, like as a separate thing. And why is that? Like, why would you buy those and not this? Or is that meant to be you can buy this and then add these later?
Yeah, exactly. So it's meant to, if you are planning about doing the bidirectional, it's something in the future, and you still want an 80 amp charger, you can buy this. But this, I'm curious, I wonder if this will even charge other vehicles. Like the Ford system will charge other vehicles on AC.
Ford, yeah.
I've charged our Lucid Air on Tom's Ford Pro station.
Yep.
And that actually comes with the truck at no charge. So this does not.
Yeah, it's almost $1,700.
Yeah.
And then, yeah, those things. So all this together is the 73 or 5, whatever it is.
Yeah, this whole 1, 2, 3, $7,500.
Plus
you can
install.
subtract. Well, the install's the big question mark here. Now, GM is partnering with Q-Merit, which we're familiar with Q-Merit. They're awesome. They sponsor our friend Tom's channel. Really like them supporting the community. We've also maybe have some projects coming up with them soon. We'll have to see. Should be kind of fun. GM is basically saying there's a whole configurator on the website. You can choose what you want to go for, and then they'll hook you up. You can have any installer install this, but Q-Merit can do it as well. And then it's going to get real pricey real quick. I think even best case scenario might be a lot of money. $5,000 minimum.
Yeah.
Would be my guess.
So roughly 12-ish on the install. Maybe
I think most
maybe
people,
15.
I think Tom was like $20,000 all in.
Okay, yeah.
Yeah.
Yeah, and then we're not even getting into batteries yet, so that's...
And we're not getting into batteries. And then it's like,
yeah.
well, you could just pull up a Honda generator. Or honestly, for a lot of people, you can just pull the power straight off the truck for the
Yeah.
plug. So you really have to be, I think, at this moment in time to adopt something this early, a real EV enthusiast, which is honestly this channel.
Yeah, but you're right. To really make that cost more worth it, it'd be really cool if you could sip energy from the grid when it's cheap, and especially in Colorado and a lot of states have time of use charging, and then reuse that energy back to the grid while you're still connected. You're not
this would
relying on an outage.
Totally agree. It would make so much more sense if you could just constantly, oh, we're at peak rates. Let's dump the truck even into the grid.
Super smart and integrated, yeah.
Totally. But requires a lot of utility coordination, which is really tough. And anyway, yeah, let's talk to some of the engineers on this thing, go through all the nerd stuff, and then we can end this video.
It's ready. Let's do it. Okay. So there's a power outage, okay? The Dark Star battery right now is providing power and communications to the inverter and the hub. The hub is locking out the grid so that there's no power that comes from the grid. Now it's communicating through the power shift charger back to the vehicle. They're making sure they have a solid connection between the two of them and that they've got a good ground. And the vehicle is now communicating back to the power shift saying I can give you power. And that power comes back through that to the inverter, and then back to the hub, and then to the house. All right.
Guys, you join me with Asim, whose technical title is Chief Revenue Officer, but you know more than almost any other Chief Revenue Officer I've met. Thanks so much for joining us.
Well, thank you for having me.
Of course.
Yeah,
so,
it's a pleasure.
Okay, since CRO is your title, we have to ask the cost of everything. We mentioned to our viewers it's about $7,300 on the website.
Yes.
What determines that cost? Will you have programs to help incentivize them? I went through the whole configurator, by the way. It's awesome.
Yeah.
Your online portals are amazing, and they showed like all the tax incentives and other stuff in my area.
Yeah, happy to hear that.
It was really cool.
Yeah. So I'll do a quick walkthrough, right? What is really driving the cost structure and how we're actually packaging the product. So the power shift charger is about $16.99. I think that's what's listed on the website, and then the balance of the system is what makes up the $7,300. The power shift charger, is essentially the brains, right, that connects with the vehicle and is driving where bulk of our engineering resources have gone in terms of instituting the product. Where I do see where the next generation of the product's headed is we're looking at least 40% BOM cost reduction, bill of material cost reduction, and we're pretty confident that we can get it there. And for two reasons. One is consolidating the footprint. How do we actually reduce this down from 4 boxes to 2?
Okay.
That's going to be pretty significant. And then when you take into account installation costs on top of that, right? So the total cost of ownership will actually be driven down further as well. But given that this is the first version of the product that we're launching, the Gen 1, And there's been considerable amount of engineering that has gone into it, including the safety standards that we've had to follow between the UL certification for the devices, as well as the connectivity with the vehicle itself, right? So there's an onboard inverter on the vehicle has to coordinate with the power shift charger, and there's been significant amount of testing that has gone into the product. So it's highly engineered, highly safe, high quality product, and that's really the value that we're driving for the customer for that price point.
So you're doing DC back out of the vehicle.
Yes.
Can you actually, just nerd question before that, this obviously can operate in split pack or in series. What configuration are the 20 and 24 modules in when charging? Are they at the higher voltage configuration?
They're at a higher voltage configuration.
Okay, so this is 1,000 volt capable then.
That's correct.
What is the future? Is it DC out of the vehicle? Is it AC out of the vehicle? We've seen different automakers take different approaches.
Yes.
Do you stuff the cost in every vehicle, or do you stuff the cost in this inverter at the home side? What's your impression? What's that trade-off?
Yeah. Look, I think there's two schools of thoughts around that. I think you nailed it when you said, look, it comes down to is where do you actually have that off-board power capability, right? Do you put it on the vehicle itself, or you use off-board equipment? So is it on-board versus off-board? What our belief is that in order for us to truly unlock the vehicle to home and then vehicle to grid capability, the utilities have to be able to rely on these assets. And utilities have the highest confidence in inverters today, right? Inverter technology has been entirely standardized. There's a 1547 standard out there.
Of course, yep.
And we believe that having that capability where they can visually test, validate, inspect these assets is going to be the initial unlock that's necessary.
Okay.
In order for us to be able to get these assets classified and certified as grid reliable and grid safety
And
assets.
you're going to have to go through each utility
That's
in
correct.
every, which I don't know, 1,800 of them, whatever there are out there.
Yeah, I mean, there's about 3,000 utilities
3,000,
if you count all the IOUs and the co-ops and the munis.
Yep.
But the intention isn't really to go have each utility certify. It's typically, like in California, Southern California Edison will take the lead. In New York, Con Ed would take the lead, and typically the rest of the firms will fast follow. Mm-hmm. The intention is really getting the consumer comfortable as well. So given that it is such a complex technology, and also the fact that it is nascent, the best way to unlock that capability, build confidence our belief is that it's through the offboard architecture right now, right? Mm-hmm. Because it gets the installation network comfortable. If you move all of that technology into the vehicle, now if you think about after servicing and sales, including the integration with the grid, a lot of that now you rely on the service technicians who have to service the vehicles. So from an after sales perspective and the total cost of ownership of the product, it's a matter of trade-offs, right?
Yeah.
So for us, we believe that the building trades or the electricians that are responsible for wiring, for the panels, if they actually get comfortable with this equipment, adopt and understand it, they're far more equipped in order to do this than to have vehicle technicians get qualified and take that complexity on.
Yeah, it makes sense, but it also seems a little bit redundant into the future. I understand why today this makes sense, because you also have inverters in the truck
Absolutely.
that are running your offboard power systems
Absolutely.
and everything. It'd be really cool to see that all tied in, maybe for next generation or the double next generation come together.
I think the true unlock will happen is if the vehicle onboard inverter is able to deliver power at the same power quality requirements as the standard offboard inverter. Mm-hmm. And that drives up the price point today for the technology that we use, because it doesn't have to satisfy those power quality standards for the grid.
Sure.
And you're absolutely right. It removes the redundancy. Now you don't need two sets of inverters, right? So it actually is a more cost-efficient solution. Arguably it's also a more efficient solution. But it comes down to is, again, the trade-off for where should that product cost reside.
Right.
Does it drive in the price point of the vehicle, or it's a discretionary piece of equipment that the customers choose to invest in? Whereas, should the BOM for the vehicle bear that, because every customer then has to pay for that, for that onboard inverter, for that standard.
Totally makes sense. I love the approach of inverters are a known quantity right now. And to get any Because right now, this is a pretty choked system. This is pretty day one.
Yes.
There can be a lot of software unlocking for it. Like, for example, right now, we can only send power through the system like it is right now when we're completely disconnected from the grid.
Yes.
And in the future, especially when you pair it with your battery systems, which I want to ask you about this in a little bit, you will be able to do some dynamic power sharing.
Absolutely. I mean, the system becomes more valuable when you have stationary storage bundled with it.
Totally.
It
Absolutely.
becomes far more flexible. It becomes far more interoperable. It also gives you the flexibility to be able to draw power from stationary storage versus the EV. And then when you couple it with the solar system, then you have the full independence, right? Because you can charge any of your storage resources, whether it's the EV or the stationary storage. And then you can move power around all these assets, right? Between your home and your vehicle, the stationary storage system. So that's the future that we believe, is going to truly create that value for the customer, that they're willing to invest in this technology. The other piece I would also argue is, and it's not really an argument, more so of a trade-off. As you think about getting people comfortable with the technology, the inverters are pretty standard, right? The solar installers are very, very comfortable with
This
this.
supports solar already out of the box, right?
I'm sorry?
This one will support solar.
Yes.
Okay.
This one will support solar. And so the technology is, fully standardized. The MID, which is, integrates with the panel, right? That technology is actually moving on a very, very different S curve where smart panels are coming out.
Yeah.
A lot of what we see the next generation is going to be like your panel has this integrated capability.
Totally.
So we see the future there. So as the market evolves, there's going to be an evolution there as well. And then more importantly, I think as the ISO standard gets adopted for bidirectional charging.
Right, which will be 15118-20.
That's correct. In that scenario, the power shift charger, which is our product, then becomes interoperable with non-GM assets.
Right.
So as you now think through each of these technology components and you look at their S curve of evolution, each of them are on their own track, but eventually we see emergence happening where we believe that off-board capability is going to actually get there a lot faster than onboard capability because of the convergence of technology and the level of investment that's going in for different reasons in different product categories. So that's just another trade-off in terms of why we invested and why we decided that an off-board DC system right now is the best entry point for our customers.
Yeah, it makes a lot of sense. I mean, I think right now the way I look at it is this is for the energy enthusiast. This is for someone who buys, like for me, honestly, Silverado EV. I want to have the coolest tech. I want to follow the software upgrades. I want to add the battery systems. But maybe in the future, Gen 2 is better. What do you think? How far away are we from a Gen 2? You've mentioned it a couple times.
Yeah. So I think, look, the product cycle, it took us about 2 years to launch this. We expect that we're going to compress that by, at least 50%. So in less than a year, we'll be able to move fast and launch the second generation of the product. I would say that, it seems like, look, there's a lot of complexity to take on, and this is really targeted towards energy enthusiasts. But once you have, between how we've actually tailored the whole experience, between how you buy the product, how you get it installed, how you configure it, how it works with the app on the vehicle, it's set and forget. It's an investment you make once, and it may seem overwhelming, but we're taking on all the complexity, right? So we actually believe that there's a market we can unlock where customers, when they're going in and buying the EVs, can make this investment, which is future-proofed as well. So if you want to, add more solar, you want to integrate with your storage system, it'll all be capable. And a lot of software, is technology that resides on these systems. So I have a different perspective. Yes, maybe energy geeks like us are going to be the first ones to buy them.
Yeah.
But fast following, I do see an opportunity where we're taking on and removing all the complexity for the customer. We see this as a long-term investment. As for second generation of the product, what our core focus is, again, driving down the product cost and driving down the total cost of ownership in the context of installation costs. When you factor those two in, we believe that that's going to again be another major driver for adoption. And then I think the third piece is really coming down to is market formation, which is true now, which is true for future generation of the products as well. Where the true value happens when you say an EV is a grid asset is where the customer can either save money or make money simply, right? And in order for that to happen, the grid and the utilities have to start forming the market, have the right market signals, whether it's time of use tariffs, whether it's demand response programs, whether it's battery incentives. And we expect that, as our utilities are very bullish on the system, right? That we expect that there's going to be a level of incentives that they'll be willing to offer up as they do on the unidirectional portfolio. Because they would make the correlation that not only is it driving electrification with EVs, which is what they want, and which is a lot of what their regulatory mandates are, but also now they can use that asset as a flexible grid resource.
Totally.
By investing in this additional
Yeah,
equipment.
tapping into your battery when they
That's
need
correct.
it for peak. So we are close on time, but I just want to ask you one last question.
Yes.
Which is, this is a bit future. Perhaps we should do a whole video on this when it comes.
Yeah.
But you'll have two variants of the battery pack, up to 35 kilowatt hours usable.
Yes.
And what energy chemistry is this? Is this LFP?
LFP.
Hell yeah, that's awesome.
Yes.
We love that for stationary. So what are the two variants?
So it's I think it's 17.5 kilowatt hours, and it is 11 kilowatt hours, if I'm not mistaken.
Okay, and
so
stackable.
5 and 7, they're stackable.
Yeah.
And so you can get them in 5 kW or 7 kW
Yep.
at these modules, and then you can stack them up as high as 35. But they're actually two different towers, and then you have one standard controller that sits on the top, which is this.
Okay, so this is the control box
That's
for
right.
it. And there's no DC to DC link so that you could charge the vehicle off of these directly.
Not yet.
Not yet. Okay, because that would be slightly more efficient than converting back to AC and then using the onboard charger to go DC. But we're talking small numbers, maybe round trip, 85% efficient, something like that.
Yeah, I mean it's a small amount of loss.
Yeah.
We are looking at DC to DC decoupled systems.
Yeah.
I personally am pretty bullish on it.
Yeah, same. I like the
yeah,
idea.
I like them a lot. I think they're actually much easier to install and configure, and also much more efficient. And we are actually investing in looking at that product category. But the first launch product will not have that.
Right, sure, makes sense. But this is all pretty cool. I mean, it's early days for stuff like this. It makes so much sense. I've been talking about, integrating our vehicles with our electrical grid
Yeah.
for so long. We're starting a whole new channel around this. It's like something I'm fascinated with. So hopefully we'll be able to cover your progress as you guys move forwards, come out with new things, talk about software integration. I always see you at the Interop conferences. Your team's hardcore on
Yeah.
making sure that all works together. So, yeah, shout out to the GM charging team. They're actually awesome.
Yeah.
really, really cool
well, we
guys. Yeah.
appreciate all the love.
Yeah.
And, we feel actually very, very strongly and passionately about the mission you're on. You're at the tip of the spear, educating all the people around, right? All the opportunities with EVs and energy. So kudos to you for
Yeah,
going
thanks.
out and talking to the world.
Yeah.
And exciting people about our products and services. And, we're right behind you.
Yeah, hell yeah. Well, let's do a video on the battery stuff when this comes out. When
All right,
we can get more
absolutely.
into it. Maybe we can come over, do a test house or something like
Yes.
that and showcase this. I want to show the app. The software is the most important piece.
Yeah.
I have a friend with I'll just mention a Tesla whole system, and it's amazing, the app, all the data. So I hope you guys benchmark that and give us everything we want to see.
We're going to deliver a better experience.
Oh, cool. I love
Yes.
it. That's awesome.
Yes.
Very cool.
That's the
thanks
challenge.
for joining. Really
Yeah,
appreciate it.
thank you very
Yeah,
much.
Thanks.
All right.
Well, we spent a lot of time in this garage together.
We're the last people here.
Yeah, I know. They're trying to get us out of here. I don't even know what time it is.
9:30.
Oh, it's not that late.
No.
Okay.
Mine is young.
I would guess I just flew to the West Coast, so it feels a lot later. Essentially, this type of stuff is the future. This feels pretty rudimentary, pretty early, pretty expensive. I know people will install it. We met people here who are going to install it, and it's going to be really cool to follow the progress. But yeah, so we're getting kicked out right now. We're getting yelled at. But anyway, thank you guys so much for watching another Out of Spec Reviews video. What do you think about the energy solutions? Let me know. I would love to explore this a little bit more. Energy channel coming probably by the end of the year, early next year, something like that. And damn, pretty sick. Thanks so much for watching. See you later. Bye-bye.